welcome to Eureka Math. I'm Mr. Schenkel. Going to be helping you today with Algebra Module 1, Lesson 14. Let's get started. Okay, today we're dealing with inequalities, so we're going to consider the inequality x squared plus 4x is greater than or equal to 5. And we're just going to try to come up with some values that make it true. So we want at least two positive values that make the statement true, and at least two negative values that make the statement true or false. All right, so here we go. I don't know. I'm going to try. I'm just going to try a 1. Let's say what happens if x equals 1. So if I put x equals 1. What will happen? Well, I get x squared is 1 squared. That looks like a J. X squared is 1 squared plus 4 times 1 is greater than or equal to 5. And then I can simplify and say, well, 1 squared, that's 1, plus 4 times 1 is 4. And is 5 greater than or equal to 5? And the answer is yes, it is. So x equals 1 will make it a true statement. And it looks like anything bigger will also make it a true statement, because all I got to do is get bigger than 5. So I could say x equals 2, and that would be if I tried it, x equals 2. Let's do that in a different color. If I tried x equals 2, then I would get 2 squared plus 4 times 2 is greater than or equal to 5, and 2 squared is 4 plus 4 times 2, that's 8. So that would be 12 is greater than or equal to 5, and that's also true. So it looks like if I just pick a number, any number bigger than 1 or bigger, then it will make it true. And that means that the numbers that will make it false, would be something other than that. So I've got a couple of positive numbers, x equals 1 and x equals 2. That makes the statement work. So let's try some negative numbers. All right, so let's see. If we try some negative numbers, let's try maybe x is, let's see what negative 1 does for us. X equals negative 1. Well, if I plug that in, that would give me negative 1 squared plus 4 times a negative 1 is greater than or equal to 5. And let's see what we get. Well, negative 1 times negative 1 is 1. Plus a 4 times a negative 1 is a negative 4. And 1 and a negative 4 put together is a negative 3. Is negative 3 greater than or equal to 5? No, it is not. So that one's not good. It doesn't make this statement true. So negative 1 is not a solution, and I'm going to need to keep looking. So I want maybe my negative 1 to get a little bigger when I square it. So maybe negative 3 would give me a 9, and maybe that will work. I don't know. I'm gonna go a little bit bigger and say maybe a negative 4. So let's go back here and try x equals negative 4. And if we plug that in and try it, we get negative 4 squared plus 4 times negative 4, and that's greater than or equal to 5. Let me stick that 5 in there. So let's see what we get. We get negative 4 times negative 4 is 16. And then a positive 4 times a negative 4 is a negative 16. And that gives me 0 is greater than or equal to 5. And we got closer, but still not true. So it looks like the higher I go, maybe I can get to that number being a little bit bigger. So I don't know. Let's try -5. Let's just try the next one. Okay, so let me try this again. We'll try x equals -5. X equals a -5. Let's try that. So that would give me a -5 squared. Oops, squared. There we go. Plus 4 times a -5. And that's greater than or equal to 5. Okay, let's see if that's true. -5 times -5 is a positive 25. And then a positive 4 times a -5 is a -20. And that gives me 5 is greater than or equal to 5. And now it's true. Now it's true. 5 is greater than or equal to 5. So it looks like if I go -5 or smaller, that will work. So maybe x is -5 and maybe x is a -6. Let's just do those. So I know those are solutions that make it true. I've got x equals a positive 1, x equals a positive 2, x equals a -5, and x equals a -6. I know those all make it a true statement. All right. Should your 4 values also be solutions to the inequality x times the quantity x plus 4 is greater than or equal to 5? Well, I can substitute and find out, and that's what we're going to do first. And then we're going to think about another way maybe to do this. So let's substitute all 4 of our values and see if it still makes the inequality true. Well, let's start with x equals 1. So that would be 1 times the quantity 1 plus 4 is greater than or equal to 5. And that would be 1 times 5, which is 5, is greater than or equal to 5, which is true. So 1 checks out. Let's check the 2. That would be 2 times the quantity 2 plus 4 is greater than or equal to 5. So that's 2 times 6, which is 12. Is that greater than or equal to 5? Yes, it checks out. So that one's still right. Let's try the negatives. So let's do a -5. So I've got -5 times the quantity -5 plus 4 is greater than or equal to 5. Well, a -5 and a positive 4 is a -1. So I've got -5 times a -1. And -5 times a -1 is a positive 5, which is greater than or equal to 5. So the -5 for x checks out. Let's try the -6. That would be -6 times the quantity -6 plus 4 is greater than or equal to 5. And a -6 and a positive 4 gives me a -2. So I have -6 times a -2. And -6 times -2 is a positive 12. And that is greater than or equal to 5. So that one checks out. So they all worked again. And the question is why? Why did they all work again? Well, if we take a look at our original inequality up here, this one at the top, and I specifically pay attention to the left side of the inequality, that x squared plus 4x, I see that there is a common factor x in both of those terms. X squared has an x and 4x has an x. So I can use the distributive property to factor out a common factor. And that does indeed give me x times the quantity x plus 4, because x squared divided by x is x, and 4x divided by x is 4. So using the distributive property, I can see that the expression on the left side of this inequality didn't change. It looks different because of the distributive property, but it's still the same value. So I didn't really have to substitute all of those values in to know that they were all still going to work if I recognized that the distributive property was employed here to make an equivalent expression. on the left side of the inequality. So instead of substituting for the next one, let's see if we can recognize anything happening that would assure us that all of these solutions would still be intact. Well, if I look at the x squared plus 4x, and then I look down here at 4x plus x squared, it looks to me like all we did was change the order of addition. And that would be the commutative property of addition was being employed. So I know that we can add in any order and we get the same answer. So that tells me that the solutions will still be good because of the commutative property of addition. All right, part D. Let's take a look here. What's happened from our 4x plus x squared to here? We've still got 4x plus x squared, but now I see a subtracting of 6 from the left side, and if I subtract 6 from the right side, 5 minus 6 is a negative 1. So what did we do here? Well, that is the additive identity property. As long as we balance the equation, add a negative 6 to both sides, we know that the inequality is still balanced. So I know that those solutions that I came up with in part A are still going to work because nothing's changed. I've made it look a little different using some identity properties, but it's still the same inequality value. All right, and then the last one, well, let's see. What's changed here? Well, it looks like if I multiply everything here by 3, not there. If I'm multiplying everything up here by 3, what's 3 times 4x? 12x. What's 3 times x squared? 3x squared. And what's 3 times 5? 15. That's the distributive property. And that also creates an equivalent inequality. So I know all of my solutions still work. Okay, so using the properties of inequality and, the properties of equality and commutative property and distributive property, we can see that they all are the same inequality. Statement looks a little different, but all of the solutions remain the same. All right, exercise 2, find the solution set to each inequality. Well, the solution set would be what x would have to be to make the statement true. And inequalities are very similar to equations, so I'm just going to solve for x, and that means isolate x. So I'm going to subtract 4 from both sides to balance the equation. I get x is less than or equal to 7 minus 4 is 3. And then I'm going to put that on a number line. So I want to graph this. X is less than or equal to 3. Well, I just need 3 on my number line somewhere. It doesn't matter where it is. I usually put it in the middle just so we can see what's happening. Sorry, that's not a negative 2. That's a 2. And then to the right would be a 4. And now I want to include the 3. So I'm going to use a solid dot on the 3 to include it. It's like it's shaded in. And then everything less than 3 is also a solution, so I'm going to shade to the left. So the shaded portion of my graph is my solution. Those are all my values that will make the statement true. All right, let's go B here. I can rewrite this m over 3. I want to rewrite that as 1/3 m. I want that to be a coefficient multiplied with m. And then I'm going to just find the answer. Okay, so subtract 8 from both sides. That gives me 1/3 m is not equal to 9 minus 8, which is 1. And then I'm going to multiply by reciprocal here to isolate the variable m. That's 3 over 1. And that gives me m is not equal to 1 times 3, which is 3. M does not equal 3. So let's put that on a number line. I'm going to put a 3 here in the middle. This would be the 2. This over here would be a 4. And then I need to say what the solution set is. Well, I know it's not 3, so I'm gonna circle the 3 to say not 3, but everything else is a solution. So everything shaded to the right, everything shaded to the left, but not 3. All right, there's our solution set for part B. C, well, I've got y's on both sides of my inequality, so I'm going to fix that first. Subtract 7y from both sides. And that gives me y plus 4 is less than negative 2. Add 4 to, subtract 4 from both sides, undo addition with subtraction. And that gives us y is less than, negative 2 and negative 4 is negative 6. Y is less than negative 6, and let's graph that. So I just need the negative 6 in here somewhere. I'll put it right in the middle. This would be a negative 5. This would be a negative 7. And then graph it. So not negative 6, open circle, but everything smaller, shade it to the left. All right, part D. We're doing the distributive property here to simplify the left side. So 6 times x is going to give you a 6x. And then 6 times a negative 5 is a negative 30. And that's greater than or equal to 30. And then isolate the variables. So I'm going to add 30 to both sides. And when I do that, I get 6x is greater than or equal to 30 plus 30 is 60. And then I'm just going to multiply by the reciprocal of 6, which is 1/6. And if I do that, that will isolate my variable. X is greater than or equal to 60 divided by 6 is 10. And in order to graph that, I'm going to put the 10 on here. One number smaller, one number bigger, and then graphically say what this is. Well, greater than or equal to 10 means I want to include the 10. That's a solid dot, and bigger numbers are to the right, so I shade to the right. And those are the solution values for that inequality. All right. Last one, looks like a couple of distributive properties. So 4 times x, that gives me 4x. 4 times negative 3 is a negative 12. And that's greater than 2 times x is 2x, and 2 times negative 2 is a negative 4. And then we just go to work getting the variables all on the same side. Subtract 2x from both sides. That gives us 2x minus 12. Is greater than negative 4. Still working on getting the variable isolated, so add 12 to both sides. That gives us 2x is greater than a positive 8. And then multiply by the reciprocal of 2, which is 1/2. And we get x is greater than 8 divided by 2, which is 4. And then to put that on a number line, 4 is there, 5 is a little bit bigger, 3 is a little bit smaller, and then what's our graph look like? Well, it's not 4, open circle, not 4, but everything bigger. So it will look like that. Okay, so no problem so far. And solving inequalities looks like just like solving equations. We just use the properties of equality and isolate the variable. And when we're done, the variable tells us what it's equal to. So let's take a look at a few more. Negative 2f is less than negative 16. Well, let's just go about solving this like we would. I've got a negative 2 as my coefficient, so I'm going to multiply by the reciprocal of negative 2, which would be a negative 1/2. And if I do that to one side, I have to do that to the other side to balance the equation. And when I do that, I do get f all by itself, which is what I want. And I would say f is less than, well, a negative 16 times a negative 1 is a positive 16. And a positive 16 divided by 2 is 8. So f is less than 8. All right. Well, it was easy enough. So then I would go about, putting that on a number line so I can see what the solution is. So let me do that down here. So we've got some room. I'd have an 8 in the middle, and then a little bit bigger is a 9, a little bit smaller is the 7. F is less than 8, so I want to say not 8, open circle, but everything smaller. So it looks like my solution says anything smaller than 8 will make the inequality true. Well, let's test that. Let's choose a 0. 0 is smaller than 8. It should be part of the solution set. So if I took my original inequality and I put a 0 in for f, that would give me negative 2 times 0 is less than a negative 16. And negative 2 times 0 obviously is 0. Is 0 less than negative 16? No, it is not. 0 should have been part of my solution set, but it didn't make the inequality true when I substituted 0 for f. What has happened? Well, if you notice back here, when I multiplied by a negative, when I multiply by that negative, it changes things because that's the opposite of 1/2, right? So when I talk about the opposite, my inequality symbol must change to its opposite. So when I multiply by a negative, or I divide by a negative, if you do that, you have to change your inequality symbol. So let's go back here. That means my graph is wrong. That means this part here is wrong. And let's go back and see if we can fix this. Negative 1 times a negative 2, that's a positive 2 over 2, which is a positive 1f, which is what we want. We just want to get the f all by itself. But when I multiply by a negative, it changes my symbol to its opposite. So instead of less than, now I have to talk about greater than because I multiplied by an opposite. And on the right side, that means I would still get 16 divided by 2, which is 8. So f is greater than 8, we think, will be the solution. Let's check that. Well, if I graphed it, it would be, I'd have my 8 in the middle, a little bit bigger 9, a little bit smaller 7. And then I would say, well, greater than 8, that means not 8, open circle around the 8, but everything bigger is to the right. And so anything bigger than 8 should make the inequality true. So let's try 10. 10 is bigger than 8. It's part of my supposed solution set. So let's just try it out. So I get negative 2 times 10 is less than negative 16. Well, negative 2 times 10 is a negative 20. And that indeed is less than negative 16. So I found the solution set. And the key is, if I divide by a negative, or I multiply by a negative reciprocal, I have to change the symbol if it's an inequality. All right, so with that in mind, we can solve the rest of these. And for b, I'm going to rewrite this. Instead of negative x over 12, I'm going to write it as a coefficient, negative 1/12 x is less than or equal to 1/4. And then to isolate the variable, I'm going to multiply both sides by a negative 12 over 1. The reciprocal of negative 1/12 is a negative 12 over 1. So I'm going to do that to both sides. And that's going to eliminate my coefficient, which gives me x. And I have to remember, since I multiplied by a negative coefficient, I have to flip my inequality symbol. And then I can continue to simplify. 1 times negative 12 is a negative 12 over 4, which is a negative 3. So x is greater than or equal to a negative 3. And if I needed to graph that, I would just make sure I had the negative 3 on there somewhere. To the right would be a little bit bigger, negative 2. To the left would be a little bit smaller, negative 4. And I just need to say, yes, negative 3, solid dot, and everything bigger, that's to the right. So my graph of the solution set would look like that. All right. Let's see. C. Subtract 6. Subtract 6. That gives me a negative a, or negative 1a, if I want a coefficient there, is greater than or equal to 9. And then I'm going to multiply. Well, instead of multiplying by reciprocal, which I think is the best thing to do to make sure you can handle fractional coefficients, you could also divide, right? I could divide by a negative 1. Balance the equation by dividing by a negative 1. And that gives me the negative 1's cancel out. I get a. And on the right side, 9 divided by negative 1 is a negative 9. But what is my inequality symbol? Well, since I divided by a negative number, I have to flip my inequality symbol. A is less than or equal to negative 9. And then I could graph that. Just need a negative 9 in there somewhere. Negative 9. A little bit bigger would be negative 8. A little bit smaller would be a negative 10. And I just need less than or equal to. So less than or equal to negative 9. I want to include the negative 9 because of the equal sign. And then everything smaller is to the left. Left is less. And that is the solution set in graphical form. Any number, not negative 9 or smaller, will make it true. All right. Last one, I see maybe some distributive property that has to happen first. So negative 3 times 2, that's a negative 6x. A negative 3 times 4, that's a negative 12, is greater than 0. And then just go about isolating the variable. So add 12. That gives us negative 6x is greater than 12. And let's do the division again. Divide by negative 6, divide by negative 6. That gives us x. Since I divided by a negative, I flip my inequality sign. And 12 divided by negative 6 is a negative 2. So x is less than negative 2. And to graph that, negative 2 in the middle. Negative 1's a little bigger. Negative 3 is a little smaller. I don't want to include the negative 2. So that's open circle, force field. And everything smaller is to the left. Left is less. So there's my graph of the solution set. All right, and then lastly, just to drive home that point of why we have to flip that inequality symbol, I'm going to solve this in two different ways. the first way, I'm going to end up with a negative coefficient of my t, my variable t. And then I'm going to change it so that it's not going to be a negative coefficient. And we'll see what happens. So here we go. We're going to solve a negative 4. So I'm going to start with this positive 2t and a negative 18t. And I'm going to combine those like terms. And that's going to give me a negative 16t. And then also on the left side, I see a negative 4 and a negative 14. I can put those together. That's a negative 18. So negative 16t minus 18 is greater than a negative 6 minus 100t. All right, and then if I try to get these all on the same side, well, let's do this. Let's go plus 16t to eliminate that t. And if I do that, I get negative 18 is greater than a negative 6, and a negative 100 and a positive 16 would be a negative 84t. And now I'm just trying to get the t all by itself, so I'm going to add 6 to both sides, and that gives us a negative 12 is greater than, greater than a negative 84t. And then I would have to divide by a negative 84, right? And when I divide by the negative 84 is when I have to change my inequality symbol. So I get t on the right side, and then this symbol has to flip to the other side. So t is greater than negative 12 divided by a negative 84 is a positive 7. So t is greater than 7 is our solution set, anything greater than 7. Well, then we're going to think about, what if I multiplied through by a negative 1/2, and I changed every term in our inequality here by multiplying through by a negative 1/2. What would happen? Well, if I do that, I would get negative 4 times a negative 1/2 is a positive 2. Right? Basically, I'm changing the sign and finding half of whatever was there before. So a positive 2t becomes a negative t. Half of 2 is 1t. Negative 14 becomes a positive 7. A negative 18t becomes a positive 9t. I hope I remember that's a 7. All right, and then is greater than, well, negative 6 divided by a negative 1/2 would be a positive 3. And a negative 100t multiplied by a negative 1/2 would be a positive 50t. So positive 50t. Okay, and then if we go about combining like terms again, I've got negative 1t and a positive 9t. If I put those together, I get 8t. And then a positive 2 and a positive 7 gives me a positive 9. Is greater than, well, 3 plus 50t. And now if I combine, if I get my t's all on one side, I can subtract 8t, subtract 8t, and we get 9 is greater than 3 plus, going to be a positive 42t. Okay, trying to get the variable isolated, so I'm going to subtract 3 from both sides. I get 6 is greater than 42t, and then divide by 42, divide by 42, and we get t is less than 6 divided by 42 is 1/7.